When a heavy fog rolls into a city, it looks like passive, gloomy weather. Look closer, though, and you will find these neon pink bacteria actively swimming and dividing inside the water droplets. This airborne life is incredibly dense. A single volume of fog water the size of a thimble holds roughly 10 million bacteria. For decades, atmospheric scientists assumed the lower atmosphere was a sterile transit tube. Any microbes swept up into the clouds were thought to be passively drifting, slowly decaying under harsh ultraviolet radiation. Into this sky, humans release massive amounts of volatile organic compounds, specifically a toxic chemical called formaldehyde. Large natural events, like forest fires, choke the sky with this compound, but industrial factories and millions of vehicle tailpipes also constantly pump formaldehyde directly into our urban environments. Once formaldehyde accumulates in the air, it stalls ordinary atmospheric chemistry. The chemical reacts with sunlight to form stagnant, dangerous ozone smog that blankets our cities and damages human lungs. Yet, given the sheer volume of toxic chemicals we emit every single day, the math on atmospheric smog doesn't entirely add up. Something invisible is quietly scrubbing the sky clean. The cleanup crew goes to work at night, specifically when calm, humid conditions settle close to the ground, forming radiation fog. Researchers at Arizona State University analyzing this specific type of weather discovered that these suspended water droplets act as floating, highly active aquatic ecosystems. The apex predator of this microscopic world is a genus of bacteria called Methylobacterium. These microbes lay dormant in dry air. The moment fog forms, they wake up. To survive the harsh environment and intense UV rays, they immediately secrete a specialized pink-pigmented natural sunscreen. Fog operates as a temporary biological incubator, selectively waking up and protecting a highly specialized microbial workforce. That workforce is exceptionally hungry. Methylobacterium actively seek out and consume the toxic formaldehyde pollution floating in the air. Formaldehyde is a severe toxin. If too much accumulates inside a cell, it binds to proteins and physically jams them, causing irreversible damage. To safely process this poison, the bacteria rely on a physiological gatekeeper called the lanthanide switch. When trace rare earth metals enter the droplet, the bacteria activate a specialized enzyme that only functions when these metals are present. Once activated, this enzyme catches the incoming formaldehyde molecules and rapidly fractures them apart. Immediate detoxification is the priority. The bacteria convert the dangerous fragments of the chemical into harmless carbon dioxide, venting it safely into the droplet. Through the serine cycle, the microbes route remaining carbon fragments to build new structural components. Supported by this chemical breakdown, researchers observed these bacteria physically growing, expanding, and dividing directly inside the fog. Devouring toxic pollution operates as an aggressive, hyper-fast survival mechanism, keeping the droplet's internal environment safe enough for the bacteria to reproduce. This biological consumption happens at a staggering rate, roughly 200 times faster than ordinary chemical reactions can account for in cloud water. To deal with factory emissions on the ground, human engineers often build bio-trickling filters. These are massive industrial tanks filled with wet bacteria-covered surfaces designed to scrub exhaust gases. Earth's radiation fog is functionally identical to those engineered systems, operating on a planetary scale. While the city sleeps, this floating microbiome works the night shift. It scrubs the air of smog precursors before the morning sun has a chance to bake them into toxic ozone. These fog events act as a temporary, naturally occurring infrastructure, a planetary-scale filter that degrades urban toxins before we even wake up to see it.